Here we go. We are talking about inverse functions, right? Now, if you think about, ooh, that isn't even how you spell function. Look at all this. Look at this mess I'm making right here. We don't want that to be there. And we don't want inverse functions are so fun that I added an extra N to the word function. That's how fun they are. Functions just mean fun. Although they're inverse functions, so would that be the opposite of fun? When we're talking about inverse functions, um, basically what we're doing is swapping the domain and range is technically what happens when we're dealing with inverse functions. So say I have this function that's like f of x equals x plus 4, right? X plus 4. And say I have this set A, and we could call it our x values, right? Say I have a set A, which is my x values, right? And if I made my set A 1, 2, 3, and 4, I could get distinct y values out, right? If I plug 1 in for x here, I'm going to get 5. 1 plus 4 is 5. If I plug in 2, I'm going to get 6. If I plug in 3, I'm going to get 7. If I plug in 4, I'm going to get 8, right? If I plug those into that function, those are points in that function. This would be my domain, right? My domain is my x values, right? This here would be my range, right? My y values. The inverse of this, those points would flip, right? For the inverse function, those points would be opposite. Like I would have, so for f of x, I would have this set of points, right? 1, 1, 5 would be a point. 2, 6 would be a point. 3, 7 would be a point. 4, 8 would be a point, right? Based on those x values. The inverse of that function, which we would write, see that little negative one there? Don't think of it in terms of exponents. It just indicates that this is the inverse. If f is the name of the function, f to the negative 1 is the inverse of that function. And it would have a set of points that would be 5, 1, 6, 2, 7, 3, and 8, 4. So what happened from one to the other? What did I do? Kind of the old switcheroo, right? I just switched my domain and range. I flipped them, right? Is the inverse. How does that work mathematically? Technically, what we're doing is we're undoing. We're saying, well, what would undo everything that's being done to X? And you can kind of think about it. If I have X plus 4 and I wanted to get back to 4, well, I want it to be X, right? I just want to get back to X and undo everything that's being done to X. In this case, I would just subtract, right? Whatever, I'd subtract 4 from everything. So the inverse of X plus 4 would be X minus 4, right? The inverse of 4X would be X divided by 4. Right? We've done inverse operations before because anytime we're solving an equation for a variable, anytime we've been isolating a variable, we're doing inverse operations. And so we kind of just want to think about a little bit what's being done. So if this right here is x plus 4, if this is x plus 4, right? Because that's what our f of x is. Technically, our f minus 1 of x is just x minus 4. And you can see that that's true, right? If I plug in 5 for x here, I'm going to get 1 back. If I plug in 6 for x over here, right, when I solve it, I'm going to get 2 back. If I plug in 7 and I subtract 4 from it, I'm going to get 3 back. And if I plug in 8 and I subtract 4, I'm going to get 4 back. So it kind of makes sense, right? Like what we're getting at. What we say about functions is that if I plug the inverse into the function, I should get x back. Like, remember when we were composing functions? So if I know that my f of x equals x plus 4, and I believe that my inverse, my f of negative 1 of x equals x minus 4, right? Because we were just undoing what was being done to x. We were doing the opposite. It basically says that if I plug f of 1 into f of x, so if I compose f of x, I plug in the inverse, I should get x back when I'm done. And so the way we would verify this is we're going to take these inverses that we're given and we're going to plug them in and see if they're true. And I'm going to do a couple of them so you're not just like going on what I'm saying here. You're going to actually see it in action. But what that means is, okay, f of x is x plus 4. That means for x in f of x, I am going to plug in x minus 4. So here I would have x minus 4 plus 4. And when I do the math on that, that's just saying x minus 4 plus 4, which gives me back x. And so we have verified that that is an inverse, right? But what about the other direction? What if I need to plug in f of x into the inverse to prove that that is we're just going to do the opposite. We're going to take this now and we're going to plug it into this x, right? So here I'm going to have x plus 4 minus 4. And in this case, you can literally see that it's going to work, right? Because we know it's just adding and subtracting 4. If those zero out, it's going to work. Because here we'd be left with x plus 4 minus 4. And you can see that the 4's would cancel and we'd be left with x. We are going to have to verify that in both directions. So a lot of the times, you're going to be able to just look at it and tell, but you still gotta, well, it's WebAssign, so you don't have to show me the work. In the beginning here, we're just talking about intuitively understanding that they're opposite. What would undo X to make it X again? Like all this stuff that's happening to X, we're going to do these opposite operations on it. And if we plug it in, it should take us back to X in both directions. So, for example, I feel like this is a super wordy. So much of what happens in pre-calculus is more wordy than anything. So say I have, for example, I have an f of x that equals 4x. and I want to figure out what the inverse is informally, but then I need to verify if I'm right. Now I'm going to look at this problem and go, well, I have 4 being multiplied to x right now, right? So the inverse function, the opposite function of that would be to divide by 4, right? If I divided 4x by 4, I'd have just x left, right? So I am going to say that the inverse function, my f inverse of x, I'm going to assume, right? I'm going to make an assumption, and that is that if I have x over 4, so that's x divided by 4, that would be the inverse function. Because here it's being multiplied by 4, which means to me the inverse would be to divide it by 4, right? And now I have to verify that. I have to verify it as if I'm plugging the inverse in for x, and then I will have to also verify it in the other direction where I've got the f inverse and I'm plugging in f of x, right? So we have to verify this in both directions. And so what this one means is I am going to take this x over 4 and I'm going to plug it in for x in the 4x, right? So I am going to take 4 times x. Well, I am going to make that x minus 4. And if I get x back, it's an inverse in the one direction, and then I'm going to have to prove it in the other direction. So this is going to give me 4x over 4, and then these would cancel, and I'd just be left with x. So I know we're good in that in that direction. Harry Styles playing in LA tomorrow, just so you know that. Speaking of one direction there, Valerie. And now we're going to come over here and we're going to do the opposite, right? Here I have x over 4, so I am going to write that as 4 times x over 4. And look, this is going to happen again, and we're going to be left with x. So we can say that they're inverses of each other. It means that they're 1 to 1. I'm not going to do this whole next problem, but what if I had, say I was given f of x equals 1/5 x. What would you assume in this case the inverse function would be? Here I'm technically saying that we have x divided by 5, right? 1/5 x is the same as saying x over 5. So what would you think that the inverse function of this would be? Yeah, but what would we multiply? Yes, right? It would be 5 or 5x, right? Technically, if we have x over 5, our inverse would be 5 times x, right? And we could prove it if we wanted to, right? Dude, I don't even know how that happened. Did you see that? I opened up a whole keyboard thing and I don't know how to get rid of it now. Maybe, oh, that's all I had to do, just click the mouse. And so we are saying that this, I can't even write anymore. F of x equals 5x is what we're saying, right? And we could do the verification, right? I could do f of f inverse of x, which just means I'm plugging 5x in for x. So I'd have 1 over 5 times 5x, right? Because that's what I plugged in. And I get 5x x over 5, which gives me x. And then we could do it in the opposite direction, right? So it all kind of works when we're verifying that way. And I could check it in both directions. But we're not always going to be given that. Sometimes we're going to be given an inverse and we just have to verify it. And they're going to get more complex as we go. Like we're not always going to ask you to find the inverse, although we will eventually be asking you to find it algebraically, but we're not taking it that far today. Today, what we're going to be doing is giving you an f of x and a g of x and saying, are they inverses of each other? Or giving you, like, let's look at this. Let me show you what I got here. Say I have a pen to write with. So, for example, if I ask you which of the functions is the inverse function of f of x equals 5 over x minus 2. And we're going to be given two choices. We're going to be given g of x equals x minus 2 over 5, or we're going to be given h of x equals 5 over x, that should be an x, plus 2. All right, how do we find out which one it's going to be? I sounded all excited. How do we find out which one it's going to be? We plug them in and we see if we get x back. How do we do that? So I have this f of x up here. I am going to plug in, let's start with, I'm going to plug g of x into my f of x. That means wherever there is an x in my original equation up here, I'm going to plug in the value that is g of x. So I have 5 over x minus 2. Well, where that x is, I'm going to plug in x minus 2 over 5 minus 2. Is that ugly? Heck yeah, it's ugly. I don't even know where to begin with that right now. Right? That's some ugly, ugly math. So I'm going to deal with it. And the way I'm going to deal with it is I am going to start by getting rid of the 5 on the bottom. Because if I multiply everything times 5 over 5, I can get rid of that 5 in the denominator, can't I? I think I can, right? So that's the first thing I want to do. I want to get rid of this 5 down here so that I'm not dealing with a fraction on the bottom. And so I am going to multiply everything times 5 over 5, right? I'm going to multiply this whole thing times 5 over 5. Because what that does is it's going to give me 25 on top. But on the bottom here, this becomes, each piece gets multiplied by 5, right? But when I multiply this piece by 5, the 5 goes away, and I wind up with x minus 5 times minus 10 minus 2, right? This is the fraction that I'm left with, and then I've got that minus 2 that came from over here. But what ultimately all we did was we got rid of that 5 on the bottom, which gives us this 25 equals x minus 12. The important thing is what it doesn't give me is x. If it was the inverse, my solution would have been x. Does that make some sense? A little bit? So what does that leave me having to do? It leaves me having to plug in h and see if that works. So now I'm going to go f of h of x equals, and I'm going to do the same thing. I'm going to take this 5 over x. Well, what goes in for x there this time? It's going to be 5 over x plus 2 minus 2. Is that ugly? Heck yeah, man. I don't even know where to start with that. Do you guys know where to start with that? Any clues as to where to start with that? I would start by going, okay, well, 2 minus 2 is 0, so that would leave me with 5 over x, right? Because these 2's would subtract away from each other. And now this becomes a multiplication problem, right? Because this is the same as saying 5 over 1 times x over 5, which gives me 5x over 5, which gives me x. So as ugly as that looked, once I just made this 2 minus 2 right here, and that was a 0, I could see that all I'm left with is 5 over x, and then that's a doable fraction. Did you say the eraser, Valerie? That's how that's one way. So we did prove, right, that h of x was our inverse because we got the x value out. So we know that h of x is the inverse of f of x. Is it pretty? No. I'm going to do one more with you. Remember, this is the only kind of problems you're gonna have. You will have to remember that like your domain and your range switch for inverse because they'll be asking you questions like that. But that's mostly just vocabulary. Most of your problems are going to be like prove this, prove this, prove it. It's all of math from here on out. Is prove it. Here's what I'm going to do. I'm going to do the next problem in blue because, you know, blue calms people down. And I could see David getting really worked up over there. Yeah, he's nodding. He's like, yeah, that's about the most I've ever seen David move. Like he's worked up. He's like, this is exciting stuff right here. Second year with David, and this is the most excited I've ever seen him about math. So, let's look at same type of problems. So say I'm given f of x equals x minus 4 over 7, right? And we want to know which one. G of x is 7x plus 4, and we have h of x that is 7 over x minus 4. And we need to figure it out. And we're rooting for g of x. Why are we rooting for g of x? Because it looks easier, right? So I'm going to start with that one. I'm going to take this g of x and I'm going to plug it into this x and see if it works. And we're going to cross our fingers so we don't have to do the second one, right? So to find f inverse of x, we are going to plug in, yeah, I guess I shouldn't even write it that way. I should write it as f of g of x, and we are hoping that it works. So I have x minus 4. So where that x is, I'm going to put in 7x plus 4 minus 4 over 7. And I'm telling you right now, it's already looking good. Because when I rewrite that top part, I have 7x plus 4 minus 4 over 7. And 4 minus 4 is just 0, which gives me 7x over 7, which is just x. So we have already proven that g of x is the inverse, and it can only have one inverse. A function can't have more than one inverse. So if g of x works, we know that h of x doesn't, which means that we don't have to do it again. Almost all of your problems are going to be verify this or verify that. More often than not, they're going to, let me see if I can find some, let me see if I can get over to the equations, the exercises. Went too far. It moved me into 1.10. This, by the way, will be the last section we do in chapter 1. So, crowd was wild. Most of them, they're just going to give you two functions and you have to prove it, right? So you'll get, I'm not doing another problem. I just want to show you what the problems are going to look like for you. So don't panic and think that we're doing more math. You're going to get stuff that looks like f of x equals x minus 19 over 4. And then you're going to get something that says g of x or h of x or whatever equals 4x plus 9. And it's just going to ask you to verify that they're inverse. Yeah, we're still only in chapter 1, but it's a really long chapter 1, Valerie. So we are going to take this and we're going to plug it into this x and see if we get x back. And if you get x back, then you can say, yes, it's verified. The first couple problems are going to take you through the steps of doing it. And then it's just going to give you the two functions and you're going to have to prove it on your own. Do you have to show your work? No, it's WebAssign. So clearly you don't have to show any work, but please ask for help if you need it, because I know that my tutoring time is super limited. It has been such a problem because they're telling me, like union-wise, they're like, don't use your apportionment time, like the time I have to do apportionment to do tutoring, but they only allotted 15 minutes in my schedule every day to do tutoring, and that isn't enough time. And they're like, well, use paper. And I'm like, well, paper doesn't understand pre-calculus. Like that's great for 7th grade math and some of algebra too, but it doesn't work for pre-calculus. And so I feel like I need to give you guys more time when it comes to tutoring availability than I can with some of my other classes. Because let's face it, I like you better, you know? So